Hello and welcome to this KNX presentation. The topic of today is KNX IoT 1.0, also known as KNX Web Services. Here on this slide we see the agenda of today. So part 1, the actual presentation of the topic. So in detail that will be about the IoT definition that I will give to you right after this slide. Some examples, some IoT examples, of course. KNX integration evolution, so the actual services, KNX services within an HTTP client actually. Then specifically also the OBIX based KNX WS definition. So WS stands for Web Services, of course. The OBIX object model, OBIX security, and then the KNX WS gateway configuration. And then there will be a part 2 in which I will give you an overview of the first test implementation. So the first KNX WS gateway. So let's start with the IoT definition. So here we see the IoT definition according to Wikipedia. And then we will check that, we will compare that with the technology that we have already today with KNX. So that what I mean is even before KNX IoT. So again, according to Wikipedia, first of all, what we need is a network of physical objects or things embedded with electronics, software, sensors, and network connectivity. And that's what we already have in KNX today. So that's a check. Second, objects able to collect and exchange data. That's the second thing that we need. So also, indeed, in KNX we have that. The famous group objects. Enabling connection between physical world and computer-based systems. That is indeed, the third item here. And that's of course also what we already have in KNX today. Then each thing shall be uniquely indeed identifiable. And that's of course what we also have in KNX today. We have the famous individual addresses, but also the group addresses. So that's also definitely a check. And then last item, is that each thing is able to interoperate with internet infrastructure. So indeed, that's what we also have already today in KNX, thanks to the famous KNX Net IP protocol. IoT examples. The most well-known example is probably the online shops that all of us already have used. Google Docs, Twitter, cloud services, like we know them from Amazon, Netflix, and also WeTransfer, just to give you a few examples. Travel reservations is also an example of IoT. And we will add to this list KNX, so specifically for surveillance, for remote access, and for security. And in the future there will be probably more aspects coming to that. I mean KNX specific aspects. Okay, next topic, the IoT integration evolution. So in the first slide here, I'll go back like more or less 15, maybe even 20 years ago. So how was KNX integrated back then? So how could we offer KNX services via an HTTP client? That is actually the use case here. So right on the right side here, we see the KNX installation. So this is standardized technology that we all know by now, of course. And in order to integrate it into an HTTP client, we needed an IP gateway. of some kind. I called it intentionally my IP gateway because there was back then no standardization for that link here. So therefore, indeed, my IP gateway, which indicates actually that we only had proprietary protocols back then. Again, there was no standardization. On top of it, the link between this IP gateway and the HTTP client was also not standardized, of course, so we had there a second proprietary protocol actually. And all this together, if we look at this constellation or at this situation, this was really hard work. Then a bit later, we had, so to say, option number 2, and what we see here is already an improvement. Again, looking at the picture from right to left, we have the KNX installation, standardized technology, but we also have now a protocol, so a standardization for in order to link the KNX installation with a gateway. We call this the KNX Net IP gateway because the protocol here that is used here is called KNX Net IP. So that's already an improvement. We have some standardization. We have standardization, sorry, but we are only halfway there, so to say, because between the HTTP client and the gateway there is still no standardization at this moment, right? So that means, okay, it's an improvement, but it's still a construction site. Now with option 3, so by which I explicitly mean, of course, IoT, KNX IoT, we see further improvement. So again, taking it from right to left, we have the standardized technology for the actual KNX installation, of course. We still use standardization for the gateway. However, this is now a different protocol. Actually, no, that's wrong. Sorry, it's a wrong statement. This is still the same protocol as we used before, the KNX Net IP protocol. So sorry, but we call this gateway differently because of the fact that there's also standardization on the other side. So again, to summarize it for you again, so we have here between the gateway and the KNX installation still the KNX Net IP protocol, but we have here on the other side also standardization, and that's what we call, this global picture is what we call the concept of KNX IoT, of the KNX Web Services, to be precise. So what we indeed see here is that we have an answer for the specific use case for integrating KNX as a service within an HTTP client. And this makes indeed the integration of KNX as a service, as a web service, really easy. Okay, looking at the KNX specifications, what we have today is well, the following. So we have in the KNX specifications the following standards: OBIX, OPC UA, BACnet WS. Also, a number of profiles have been foreseen: M2M, Enterprise, Real-Time Web, Data Archive. However, I will only present here today the combination of OBIX and Enterprise. So, looking at the OBIX object model, we see the following picture. So it all starts from the top here. So it starts with the identification of the KNX gateway. So that's an IP address. Within this gateway, a number of installations can be covered. That's what we see here. And within each such installation, there are a number of views. These views are called the the data point view, the functionality view, and the device view. And all these views are interlinked, so to say. So this is the object model that we will use for a KNX WS gateway, which is based on the OBIX standard. The OBIX-based KNX WS profiles then, that's what we see here. So this is just an overview slide. But as I said, we will only focus on this specific combination. So the enterprise profile, which means that the message exchange is based on HTTP and the data encoding is based on XML, because these are the two aspects that are covered by such a profile. In the future, we will also have then, indeed, example given, real-time web, so where the message exchange is based on WebSocket and the data encoding on JSON, just to give you an example. Okay, let's have a look at some further details for the OBIX enterprise profile. Well, it is resource oriented. That means we will use the so-called URIs, which stands for Unique Resource Identifier. The messages will be exchanged using HTTP, as said before. This profile is also stateless, which means we will only use some base commands, like the few examples here on the slides. So the put command, delete, get, post. With a put command, we have the possibility to create an object and to link that object with the provided URI, the URI that was provided in the put command. With delete, we can do the opposite, so we remove the object that was linked to that to the provided URI. The get command in order to request data from the provided URI. Post is the command in order to transfer data into the provided URI. Okay, let's have a look at an URI. So in this example, it will be we will create the URI for a temperature controller that's located somewhere in the KNX installation. So it all starts with HTTP, the IP address of the gateway. If you remember the object model, you will know that indeed we will then end up in the level of installations, of which specifically I want to address the demo installation. Each installation has a number of views, of which I want to address here in this URI the devices view. Within this devices view, I have an overview of all devices, but I only want to address one specific device, which is called temperature controller. And this is then a URI that we can use for further commands, like on this slide here. So, example given in order to perform a read request for the device. So we'll use indeed the get command and just use the URI that we just created before. So you recognize it again. This is the identification of the gateway. It's the demo installation, the devices view, and indeed specifically the temperature controller. Because of the get command, we will get a response. Well, that is at least to be expected. So what we will see in this within this response, so in the HTTP message body, is then indeed some details about this device. So it is indeed definitely the temperature controller, that's the name of the device. We will see a physical address, an order number, a serial number, the manufacturer of the device, but also the data points. In this case, there's only one, and that data point is called temperature value. Now let's try to do something with this data point. So that's yet another URI, and also another command again. Well, it's actually also a get command, but it's we need to apply it again, but with a different URI. However, different, it's not really that much different. It has just been extended. So you recognize the URI from before until here. So the device, temperature controller indeed. But then we go one step deeper in the object model, data points, and then specifically indeed the temperature value data point. So applying the get command will then render again response, and what we will see in the HTTP message body is indeed the actual temperature value. Like example given here, the actual value is, or the current value is 23.4. The response can also indicate a minimum, a maximum, and of course a unit. Okay, now let's have a look at the security aspect in combination of OBIX. And this is actually very simple to explain to you. There's actually just one statement to make here. Security procedures and authorization mechanisms are not covered by OBIX. As simple as that. So that means if you base your KNX WS gateway on OBIX, you will not find any stipulations in the KNX specifications for security procedures and authorization mechanisms. So therefore we say, or our suggestion is, to use already existing and proven technology. So you could indeed roll out either HTTPS, SSL, or DTLS in your KNX WS gateway. Maybe just one remark that I want to make here is that the VPN solutions that already today are typically used in the KNX NetIP context can still do the job, of course, but it's a bit of overkill. So you might need to take this into consideration. Okay, how is a KNX WS gateway actually configured? This is actually regardless of the standard that will be used, OBIX or any other standard, or any other profile to that extent. So this is just a general approach. Well, the KNX WS gateway configuration will be based on an ETS app actually, and this app is called the Web Service Exporter. So this is the situation. We have again on the right side the KNX installation, in the middle the KNX WS gateway, and then on the left side the HTTP client. The configuration of the KNX installation is of course contained within an ETS project. Now, in combination with this specific ETS app, so called the Web Service Exporter, we can export this KNX project, this ETS project, into the specific format that is required for the KNX WS gateway. So the KNX WS gateway can then import such file or files, and then the KNX WS gateway is indeed, how to say, configured or will match with the KNX installation. And then of course, knowing the object model, the HTTP client is indeed able to access this KNX installation in a way that I have just explained before. Okay, so that was actually the first part. Now let's have a look at the second part, which is about the first test implementation. So it will just be an overview of this test implementation that you can test for yourself, of course. So some details. It is a test implementation from KNX Association. It's based on Raspberry Pi and a KNX Net IP router, and of course the ETS app Web Service Exporter. So here we see the situation, the KNX installation linked to a KNX Net IP router, which is linked via IP to a Raspberry Pi, which is linked via IP to an HTTP client. Here we see some pictures, some screenshots. So here the configuration of the KNX WS gateway. A navigation example. So what do you need for testing this test implementation? Some details on the KNX WS gateway, so on this test implementation, of course. So the hardware is, as I said before, Raspberry Pi, well, specifically Raspberry Pi 2. This is what you need in order to set up the software, and these are the steps in order to set up the software. This is what you should know about the Web Service Exporter, so the ETS app. And these are the testing steps. Some details that you should know about the ETS project, so how you should create it or prepare it properly for the KNX WS gateway. And this is what you should know, how to use exactly the Web Service Exporter in order to prepare the configuration of the KNX WS gateway. So how to find or set the IP address of the gateway. How to set the IP address of the KNX Net IP router. And here to further fine-tune the configuration of the gateway once it is set up. And then you should be able to test the connection, to browse through the object model, and to play with the data points. And the ultimate step is indeed to send data point requests manually. That could be done, example given, with the Firefox HTTP requester, which is of course free software, free of charge software. Some details on this. And here an example. So there are still some follow-up webinars that we can recommend, but as such the webinar is now finished. And before I conclude the webinar, I want to still present a few extra slides. And while doing that, I want to thank you for being here. I want to thank you for your attention, for considering KNX. And maybe we see one another in one of my future webinars. So thanks again and goodbye.